equation matches this graph? And here's a little different look at that graph, perhaps a little bit better look. Hopefully you either got that link through the chat or send on to D2L to get it. But let's figure out a couple things about this graph. So in WebAssign, they're going to give you actually an equation to figure it out, or they'll give you the graph and give you a bunch of equations to choose from. But I want to learn it this way. First of all, it opens left and right from these vertices. So which squared term has to be positive? Is it going to be the x squared term or the y squared term that's going to be positive in this? So I'll give you two choices. X squared over a squared minus y squared over b squared equals 1. Or y squared over a squared minus x squared over b squared equals 1. So which one of these styles has to be the correct graph?
The first.
Yeah, the first one. Excellent. Because it opens left and right. So the first one is correct. Let's see if there's something else we can determine. And I think we can determine it this way. This distance from the center to your vertice, that's telling you what A equals. So A equals 3. All right, well, that's kind of pretty much half our battle there. X squared over 3 squared minus y squared over b squared. Well, b is going to be a little bit different. You can determine it from this graph. I can't really remember how WebAssign asked this particular problem, but from the graph that I gave you, you should be able to determine b quite readily. Any comments or guesses as to what b must be? 7. Good. So y squared over 7 squared, and that's it. Now you could also write it as x squared over 9 minus y squared over 49 equals 1. WebAssign should accept either of these, but you know, it's up to you. If you're going to be drawing these for me on an exam, I am going to ask that you draw the box, diagonals, and then two branches of a hyperbola that get close to but never quite touch that asymptote. So the good thing for you is that we don't really have to determine the equation of the asymptotes for this course. That's a pleasure that awaits you in college algebra. Comments or questions on example A here? Doing okay with that one? All right. Let's work with some of these. One of the things that's going to become more important in the next section is understanding which graph is which just by looking at them. So let me see here if I can find something from another class. I think I made it available to you guys as well. No, let's see, it'd be 11.4. Yeah, here we go. Which conic am I? So the easiest thing to do when you're trying to determine which conic section you're looking at is to see if there's only one squared term. If there's only one squared term in your conic section or the equation you're looking at, and it's generally of this form, then you're going to be looking at a parabola. So of these 4 equations, which one has to be the parabola? 1, 2, 3, or 4?
3.
The last one, yeah. This one has to be the parabola. Okay, and that's because there's only one term that's squared. There's a y squared term, or there's not an x squared term. So, okay, well, let's keep going. If there's 2 squared terms, then you got to decide between a hyperbola, ellipse, or a circle. Now, the next easiest thing to see is if you've got a hyperbola, because with a hyperbola, yeah, you're going to have 2 squared terms, but when those squared terms are on the same side, they'll be of opposite sign. One will be positive and one will be negative. So again, let's look back here and determine is one of these a hyperbola? What do you think? Or maybe I should say, which
Number
one's
two.
hyperbola? Yeah, number 2. Number 2 has to be the hyperbola because you've got two squared terms that are opposite in sign. One of them's positive, one of them's negative. In fact, this would open up and down as opposed to left and right. So that's a hyperbola. All right. Now, what if you have two squared terms, but they're both positive? All right. If you have two squared terms and they're both positive, then you got to look at this a little deeper. Are the leading coefficients the same? So that is, the coefficient of your x squared term and the coefficient of the y squared term, are they both the same number or are they both different? If they're both the same, then you've got a circle. If they're different, then you've got an ellipse. So let's take a look back at what we've got. What conic section would you suppose this is?
Circle. Circle.
Yeah, that has to be a circle. That's because the coefficients here are both 1. It's not really written, but it's understood that they're both 1. And the last one, you've got two coefficients. Yeah, they're both positive, but they're different. So that would have to be an ellipse. Okay. I do believe I have this handout available somewhere on our D12 website. If not, then let me know and I'll make sure it gets up there. Okay. Let's go down here and deal with this one. And let's kind of deal with it a piece at a time. First of all, I'm going to rewrite this one. So let's see. I'm going to rewrite that. Any suggestions or thoughts as to how I might rewrite this?
Change the denominators to 2 squared and 5 squared.
Perfect. 2 squared and 5 squared. Now, I do believe I've got the link there in the chat. If somebody signed in late, let me post that link again. There we go. So let's see. The first thing to determine is what's the center. So I'll let you take a look at that. If you're watching it at home later, then you can pause the video. Determine what the center is. And those of you who are keeping up with me on Desmos, let's shut this off, shut the first two off, and then move down to example C. When you're ready with example C, click this center button here. See what you get. So before I spill the beans, someone want to shoot it out? Shout it out.
Center, -3, 4.
Awesome. -3, 4. Perfect. Thank you. That's your center. Now, from there, we need to determine the points that are going to be our rectangle. So remember, I'm going to want you to draw a rectangle. That's going to mean from the center, I have to move to the left by 2, to the right by 2. And then how about in the y direction?
Up and down 5.
Up and down 5. Good. So we can actually figure out the points for that. So the center was -3, 4. That's my center. If I move to the left by 2, I'm subtracting 2 from that. So that'd be -5 and 4. If I add 2 to that, that'll be -1 and 4. Now in the y direction, I'm going to start out from center. So it's -3, 4. But this time I'm going to add 5 and subtract 5. So again, try and beat me to the punch, figure out what these are before I write them down. So if I move up 5, I'm just changing the y coordinate. That's why the x coordinate's the same. So up 5 would be at -3 and 9, and down 5 would be -3 and -1. So let's see how we did. Got our center. Booyah, there's our points for the rectangle. And you can click and see all the points that we suggested that we would have. Yay. After this, what's your next step? You've got these 4 points. It looks like we could just draw an ellipse here, right? We can't, all right, because it's a hyperbola. How do I know that this is a hyperbola and not an ellipse? I mean, if you get that part wrong, that's a major foul up there. So my son used to call that an epic fail, all right? All right, so, but it's important. It's subtle. It's really easy to do. How do I know that this is a hyperbola other than the fact that your instructor told you to?
Signs
So-
are different.
Yeah. They're negative. They're opposite signs. You got a positive term that's squared and a negative term that's squared, but they're opposite in sign. So that's it. It's a hyperbola. You got 2 squared terms that are opposite in sign. All right. So we've got that. Then what do we do? We've got all these points. What do we do next?
Draw the box.
Yeah, draw the box. And let me help you with that. There's this button here. It says rectangle. Click that. Ooh, that's pretty cool. There's your box. And then after you draw the box, what happens next?
Draw the diags.
Yeah, draw the diagonals, aka the asymptotes. That's those right there. Finally, I didn't ask you earlier, but I will now. Which way does this open, left and right or up and down?
Left and right.
Left and right. It's going to be around the axis that has the positive squared term. So that would be left and right, and bam, there you go. Awesome. You did great on that. Give yourself a pat on the back. Comments or questions on that one? Doing good there? All right, let me let you work on some of this stuff. If you have some questions as you go through it, please reach out.